Hello everyone, welcome to the module 3 of our pre-sales course. So let's see what we are going to discuss today. How to write business requirement documents that captures real need, not wishes. The difference between scope of work and BRD and why you need both. How to define scope in and out explicitly, preventing scope creep before it starts. How to get formal client sign-off on scope boundaries. The formal change request process, how to say that's extra and charge for it. How to write a technical design document that translates requirement into architecture. Common scope mistakes and how to avoid them. Here's what happens when scope isn't defined. Week 1, client asks for a feature, not in the proposal, but it's easy to add. Week 3, client asks for another integration, just one more thing. Week 5, client asks for the UI to look like their competitor's product. We changed our minds about design. Week 8, the team is working 60 hours per week. The budget is blown, the timeline is slipping. Week 12, the client is angry, you are unhappy, everyone loses. Here's what happens when scope is defined. Week 1, client asks for a feature that's out of scope. We can do it as a change request. Here's the cost and timeline impact. Week 3, client asks for an integration, not in phase 1, that's phase 2. Week 5, client wants to change the design. We need to do a CR or change request. Let me assess the impact. Week 12, project delivers on time, on budget, client is happy, the team is intact. The difference is documentation, boundaries, discipline. This module teaches you how to build those boundaries before the project starts. Because once you are deep in delivery, boundaries are 10x harder to enforce. The cost of defining scope properly is a few weeks upfront. The cost of not defining scope is chaos and litigation. Scope definition happens in layers. Each layer feeds the next. Business requirement document or BRD. The BRD is the business analyst's baby. This is their domain. Purpose: capture what the client needs, not how to build it. Okay, that's technical design document. BRD answers these questions. What problem are we solving? For whom? What are the success metrics? What features, workflows are needed? What are the constraints? The BRD is written in business language, not technical language. Here's how a BRD is structured. User stories, business requirement, acceptance criteria, constraints, and dependencies. This is not vague, this is testable. When the developer finishes this feature, you can objectively say, does it meet the acceptance criteria? Yes or no. Scope of work. The scope of work, or SOW, is the contract document. It defines boundaries. The purpose is it clearly states what is in the scope and what is not in the scope. The SOW has this structure. It has project overview, one paragraph summary of an engagement, client name, project name, duration, investment. Scope in: every deliverable, feature, or outcome that we are responsible for. Listed explicitly includes acceptance criteria. Scope out includes every feature, integration, or responsibility that's explicitly not in the scope. Listed by name include rationale on why it's out. Okay. Assumptions: what we are assuming is true, what we are assuming the client will provide. Constraints and dependencies: technical constraints, client constraints, timeline constraints. Acceptance criteria: How we know the project is done. Objective measure, right? Communication and governance. Who are the key contacts? What's the cadence of the meetings? Who approves what? Change management. How new requests are handled. A formal change request process. Who approves? How we price it. Every item is specific. Every item is testable. Every item has a boundary. Okay, so we have both BRD and SOW. Why do we need both? Right? BRD, business level requirements. What do we need to solve? SOW is project level scope. What are we delivering in this engagement? Not every BRD makes it into every SOW phase. Example, real-time alerts. User story. As a cargo planner, I want real-time alerts when capacity limits are exceeded so I can take immediate action. Priority is medium. Acceptance, alert delivered in less than 30 seconds after threshold exceeded. This is a valid requirement, but it's not in the phase 1 or MVP SOW. It's in phase 2. So in the SOW, under scope out, we write real-time alerts deferred to phase 2. Phase 1 provides daily email reports. This prevents the client from demanding real-time alerts in phase 1. Now we move to technical design document or TDD. Now the engineers take over. The TDD translates business requirements into technical architecture. The purpose of a TDD is to define how we build it. TDD sections involve architecture overview, which includes high-level system design, major components, technology stack, etc. So it can have diagrams, data pipelines, training, inference, API monitoring. What sort of technologies are we going to use? Pandas, sklearn, Fast API, Postgres, AWS, etc. Data architecture, data sources, data flow, feature store, data models. Where data comes from, how data moves through the system, where features are stored, database schema. All of this is within the data architecture. Model architecture, feature engineering approach, base model used, ARIMA, SARIMA, LSTM, etc. Training pipelines, how and when models are trained, inference pipelines, how predictions are made. Then API design, endpoint definitions, URLs, methods, parameters, request response schemas, error handling, authentication, and authorization. Deployment architecture, infrastructure, AWS, Azure, SageMaker, deployment process, how code gets to production, scaling strategy, how to handle more load, monitoring and alert, how we know if things are broken. Data security and compliance, it involves data encryption, at rest, in transit, access control, who can see what data, who access what, when, GDPR compliance, PII data, all of those considerations. Testing strategy, unit test, test individual functions, test components together, model accuracy, drift detection, performance under stress, all of those. Assumption and constraints, what we are assuming is true, technical constraints, risk and mitigation, technical risk or mitigation strategies. The scope boundary in practice. Now let's see how these layers prevent scope creep. Scenario. Week 3 of the project, a client stakeholder asks, can you also predict passenger volume? We could use that for crew scheduling. What do? Right answer, you pull out the SOW. That's an interesting idea. Let me check. You read the SOW. Predicting passenger volume for crew scheduling is not in phase 1. Phase 1 is cargo forecasting only. However, this could be a great phase 2 feature or a separate engagement. Let me assess the effort. We meet with the team leader, engineers. Adding passenger volume forecast would be 2 weeks of additional feature engineering, 3 weeks of model retraining, 1 week of API expansion, total 6 weeks, 150K in additional cost. Timeline impact, project would be delayed 6 weeks. Would you like to A. add this to phase 1 scope? It requires additional 150K and a 6-week delay. B. Move this to phase 2, separate engagement, or defer and focus on cargo forecasting in phase 1. What's your preference? The client hears this is valuable, here's what it costs, you decide. They almost always say, let's keep phase 1 focused on cargo, we will do phase 2 later. If they say, let's do it all, you write a change request, get approval, adjust timelines and budgets. You are not scrambling, you are disciplined. Let me show you how to write a real BRD. First is organize by feature area. From discovery, we have these pain points: volume forecasting, item type classification, hierarchical reconciliation, API delivery, and monitoring. So our BRD has sections: volume forecasting requirements, item type classification requirements, hierarchical reconciliation requirements, API and integration requirements, monitoring and alerting requirements. Then we write user stories. For each requirement, start with a user story. As a role, I want action so that the value would be XYZ, right? For example, as a cargo planner, I want the system to forecast total cargo tonnage 3 weeks in advance so that I can allocate warehouse equipment and staff accurately. This is good because it names the persona, which is cargo planner, states what they want, forecast tonnage, explains why, accurate allocation, not the system must use LSTM networks to forecast tonnage. That's how you would build it, not why the client needs it. Translate to business requirements. Right, now translate the user stories into testable business requirements. User story can be, as a cargo planner, I want the system to forecast total cargo tonnage 3 weeks in advance, blah blah blah. Business requirement can be, the PCE must predict total cargo tonnage for any flight on any route with plus or minus 5% accuracy 21 days in advance. This is testable, measurable, objective. Then we define acceptance criteria. How do we know when this requirement is met? Acceptance criteria has model trained on 5 years of historical data, holdout test sets achieves MAE less than 5% of actual tonnage, production predictions achieve MAE less than 5% when compared to actuals or daily. Prediction API returns results within 500 milliseconds, 99% API uptime measured over 30 days period. Each criteria is binary, met or not met. Then we prioritize. Not all requirements are created equal. Volume forecasting, critical. That's the core problem. Real-time alerts should be it's nice to have. Mobile app could have. You can classify the prioritization as must, should, could, and won't. Must means without this the project fails. Should is important but not a deal breaker. Could, nice to have. Won't, out of scope, for this phase. Identify dependencies and constraints. Every requirement has prerequisites. Example, volume forecasting depends on historical data extraction. 5 years of cargo data. Is it available? Feature store built. Feature data available. Right? This BRD or this requirement is constrained by must use existing PostgreSQL database, must integrate with existing data warehouse, must achieve less than 500 milliseconds of response time. Document this. These affects your timeline. Now we get client sign off. Print the PRD, schedule a review meeting, walk through it with the sponsor or the budget owner, the end user, the person using the system daily, the technical approver, the CTO or equivalent. Ask them, does this capture your requirement? They'll say yes, but also we need X and Y. You add X and Y, you reprioritize, you sign off. Now everyone has agreed on what needs to be built. Let's deep dive into SOW. SOW is where you draw boundaries, not with malice, with clarity. Here's an example for a real project that went wrong. Client, we need an e-commerce platform. The vendor says, yes, we will build an e-commerce platform. Then, week 2, can you integrate with our ERP system? Vendor, sure. Week 5, we need to support 5 payment processes. Vendor, okay, let's add that. Week 10, we need an inventory management module. Vendor, wait, that wasn't in the scope. Client, but how can we sell without managing inventory? Next thing you know, chaos, lawsuits, ended badly. But instead, here's what should have happened. The SOW explicitly states the scope in and scope out. Right? So the scope in is e-commerce storefront, payment processing, user authentication, order tracking, email notifications. Scope out is ERP integration, inventory management, mobile app, and international shipping. Dependencies, inventory data must be provided via API. This is the client responsibility. Now when the client asks that we need ERP integration in the week 2, you can say that's out of scope for phase 1. It's listed here. We can add it as a change request. It will take 4 weeks and cost $50,000. Would you like to do that? If they say yes, great. New PO, adjusted timelines. If they say no, that's fine. You stay on track. Notice something important in this SOW. Everything is specific. Nothing is vague. We will provide forecasting is vague. We will achieve less than 5% MAE as measured by daily actuals versus predictions over 30 days is specific. We will integrate with your system is vague. We will provide a REST API documented in Open API spec. Your team will integrate it into your dashboard is very specific. The SOW is your contract. Make it bulletproof. Now let's talk about change request process. So the project kicks off. You are on week 3. A stakeholder asks, can we also predict peak demand hours so we can schedule extra stuff? That's not in the SOW. It's a change. Here's how you handle it. Acknowledge and don't promise. You say, that's a great idea, let me assess. You do not say, sure, we will add that. You have now opened a change request process. Open a change request. You file a change request using the standard form, whatever your company has. Then you did the assessment. The PM and the lead engineer assesses the change request. Is this technically feasible? Yes. How much effort? 6 weeks, one engineer. How much costs? $95,000. What's the risk? Low, high, medium. Timeline impact: delays phase 1 by 6 weeks. And then you send a formal change request quote to the client. Then let's say the client is Jane Doe, and they need to make a decision. Now, Jane Doe has 3 options. Option 1 is approve. Yes, let's do it. I'll send a PO amendment for $95,000. You add it to the backlog, you schedule it, you deliver it 6 weeks later. Option B, defer. Too expensive for phase 1. Let's do it in the phase 2. You document that it was deferred. Phase 1 stays on track. Option 3 is rejection. Actually, we can live without this. Not worth the cost. You close the change request. Phase 1 stays on track. And then finally, you document all of this. Whatever the decision, you close the change request. If approved, CR status is an approved approval for phase 1 with PO amendment. If deferred, CR status deferred, decision deferred to phase 2. If rejected, CR status closed, rejected, decision client decided not to proceed, cost benefit not justified. This process does 3 things. Protects you. You don't work for free. You are not scope creeping without being compensated. It protects the client. They can see the cost benefit clearly. They make an informed decision. Protects the project. Phase 1 doesn't spiral into chaos. Scope is managed, timeline is managed, budget is managed. Now let's discuss about common change request scenarios. Scenario 1, client says, but we thought this was included. You pull out the SOW, you show scope out. I understand, let me check. No, this is explicitly in scope out, but we can do this as a change request. Client can't argue. It's in writing. Scenario 2 is client keeps filing change request, trying to get free work. You establish a pattern. All CRs go through the formal process, no exception. After 3 to 4 CRs, they realize you are disciplined. They stop filing frivolous change requests. Scenario 3, mid-project, you realize the original scope is wrong. You file an internal CR. We estimated 40 features. We now believe we need 60 to meet the less than 5 MAE target. This is 20 extra features, 2 extra weeks. You quantify it, you get approval, you adjust schedule. This is professional. This prevents blow up at the end. Now let's talk about technical design document, or TDD. The TDD is where engineers take over. BRD says we need less than 5% MAE on volume forecasting. TDD says here's how we will achieve it. Here's the architecture, here's the data flow, here's the model we will be using. The TDD is the engineer's roadmap. Now let's discuss about the key sections of TDD. Section 1, architecture overview. It's a high-level system design diagram, major components, right? Section 2 is data architecture. Where does data come from? How does it flow? Then model architecture. What algorithm we will be using? How will we train and serve it? API design, endpoint specification, request response schema, error handling. Deployment architecture. How do we deploy this to production? Monitoring and alerting, how do we know if things are broken? Testing and strategy, how do we test? How do we know it works? Some of the best practices: be very specific in TDD. You should not use something like, we will use machine learning. Instead, we will use ARIMA plus profit plus XGBoost with optimal combination reconciliation. Include diagrams. Words are ambiguous, diagrams are clear. Document assumptions. We assume data is available daily. If it's only weekly, timeline changes. Identify risks. Risk is model may overfit if we don't have enough training data. Mitigation, use cross-validation and regularization and any other techniques. Define success criteria. Model is successful if MA less than 5% and reconciliation error is equal to 0. Get technical sign-off. Client CTO or tech lead needs to agree with the approach before you start coding. The common TDD mistakes is over-engineering TDD. We will build a microservice architecture with Kubernetes, gRPC, and event-driven streaming. Reality: for MVP, you need a simple REST API, not a distributed system. Better, start simple, add complexity if needed. Mistake 2, skipping implementation details, right? We will train a machine learning model. That's not enough detail. You need which algorithm, which hyperparameters, how will you evaluate, how will you deploy. Be specific enough that an engineer can start coding from this document. Ignoring operational concerns. TDD focuses on development, but someone needs to maintain it. How do we monitor the model for drift? How do we retain the model? How do we roll back if something breaks? Document this in the TDD. Let me show you the most common scope mistakes. Mistake 1 is writing vague requirements. Right. So bad BRD, the system must forecast cargo volume accurately. Accurately how? Plus minus 10%, plus minus 20%. Who judges accuracy? A good BRD has the system must forecast cargo tonnage with MAE less than 5% of actual tonnage as measured by comparing 30 days of production forecast versus actuals. It's objective, testable, no ambiguity. Mistake 2 is scope creep from day 1. Week 1 kickoff. Oh, by the way, we also need real-time alerts and dashboard and mobile app. Those are out of scope. We can do them as phase 2. Client says, but they are so important. You say they are, and they are also 6 months of work, not 4 months. You don't get bullied into scope creep. You have the SOW in writing. Not documenting assumptions. You assume data will be available within week 1. Client thinks data extraction will happen eventually. Week 3 arrives, no data, project stalls. Better, SOW explicitly says client provides data extract by end of the Friday, week 1. When it doesn't happen, you can point to that assumption. The next mistake is letting scope ambiguity fester. Week 2, someone asks, does the API need to be publicly accessible? You say, we can figure it out later. Week 8, you realize it needs to be public. Architecting for public versus internal is different. Major refactor. Better, in TDD explicitly state API is internal only behind VPN, or API is public will require additional security hardening. Document it, prevent surprises. Mistake 4, not using the change request process. Client says, can you add feature X? You, sure, we will squeeze it in. Now it's not tracked, it's not costed, it's just magic. work that appears somewhere. 6 months later, you have delivered 10 untracked features. You are over budget. You are unhappy. Better the change request process. Everything is tracked, everything is costed, everything is approved. The next mistake is changing scope without updating documents. POC scope changes midstream, but SOW wasn't updated. Now, does the project patch the SOW? No. When it comes to time for final payment, we delivered what was in the SOW. You asked for extra stuff, that's why the cost is higher. The client says, but it's all the same project. There's a lot of argument, friction, relationship damage. Better is when scope changes, update the SOW or file a change request. Keep documents in sync with reality. Finally, we are going for sign off. So you have a BRD, you have the SOW and the TDD. Now you need sign off, a formal sign off. This is not optional, this is not casual. You schedule a meeting with the client sponsor, user representative, technical approver. You walk through the documents. Here's what we are building. These are the requirements. Do these match what you need? They'll ask questions. You answer. You justify if needed. Here's what's in the scope, what's out of the scope. We deliver these things. We do not deliver these things. They'll push on some scope out items into scope in. Sometimes you move them in, sometimes you raise a change request, sometimes you hold the line. Here's how we will build it. We will use this architecture, this data flow, this model. Any questions? The technical approver will dig into the TDD, make sure it's feasible. Finally, if everyone agrees, I need you to sign this document. Your signature means I have reviewed this. I understand what's being delivered. I agree to the requirements and scope. They sign the documents. Now you have legal cover. If they later say, but we thought you would do X, you show them the signature. You approve this scope. X is not in the scope. This is not adversarial. This is professional. Everyone wins. Client knows exactly what they are getting. You know exactly what you are delivering. No surprises. Scope definition is not bureaucracy. It's insurance. Here's what you have learned in this module. 1. BRD captures what the client needs, user stories, business requirements, acceptance criteria, and is testable. SOW defines the boundary, scope in, scope out, explicitly, no ambiguity. TDD translates business requirements into technical architecture, specific, detailed, and implementable. Change request process manages scope after kickoff. Every change is tracked, costed, and approved. Formal sign-off by all stakeholders protects everyone. Client knows what they are getting. You know what you're delivering. When you do this right, projects stay on track, budgets don't blow up, timelines don't slip, clients are happy, teams aren't burnt out. When you skip it, that's pure chaos. Do the work upfront, save yourself 10x pain later. So, I hope this module was helpful. See you in the next one. Thank you.